Working with exponents part 2. So we were on this problem right here, 25 divided by 5. There are 4 m's and there are 10 m's in the denominator. 25 divided by 5, that is not an exponent, so I do not use this rule down here at all. 25 divided by 5 is 5. Notice m divided by m will become 1. I have 1, 2, 3, 4, 5, 6 m's. But do you see that they're left in the denominator? So I'm going to have to put them in the denominator. If I had done subtraction, 4 minus 10, I would have had an m to the negative 6. So again, that means I started subtracting from the numerator, I got a negative, put it in the denominator. Negative 10 and 5 are not exponents, so I write them down. I have 5 a's, 1, 2, and a b, and then I have 6 b's. Now the problem here is that you see this negative right here? Again, negative tells me I'm in the wrong spot. It started in the denominator. It is not happy. So I need to pack its bags and move it so it would move up to the numerator to make it a positive. So if I had rewritten this one to begin with, a to the 5th, b, then I would have had a squared following that, over 5, b to the 6th. Again, when I see a negative exponent, it is not happy where it is, move it. Denominator moves to the numerator, so there it is, and I put them up here. The b's, there is 1b, there is 1b. Negative 10 divided by 5 is negative 2 in the numerator. A's, 1, 2, 3, 4, 5, 6, 7. I have 7 a's, they're in the numerator. Notice the b's are in the denominator, 1, 2, 3, 4, 5. Now, if I had done this problem from the beginning, I'm going to write it down again down here. Negative 10, a to the 5th, b. Then I brought my a squared up because it was negative. B to the 6th. Sorry, I had a 5. When I do the division, these are not exponents. That's where I get negative 2. Notice these two are being multiplied, so when multiplying, add my exponents. 5 plus 2 is 7. Right here, these two are being divided. When dividing, subtract. I would have had 1 minus 6, which is a negative 5. And because I started it with the numerator, it was negative in the numerator. Put it in the denominator. So my rule says, if negative exponents what we say is flip position. So that means numerator, denominator. So if I have a to the negative 2 over b, this is negative, it's going to move. So I'm going to say a squared in the denominator. B didn't move, it's not negative, so that leaves me with a 1 in the numerator. Alright, let's practice some examples on this video before you go do the assignment. So they left us several here. Now, this problem here, this 3 is going to everyone, so this is how I suggest you write it. 3 cubed. Then I'm going to do W5 cubed, and Z squared is being cubed. When I write this one, the squared goes to both. So parenthesis 5 squared, parenthesis W squared. Then I can apply everything. So this exponent needs to distribute. I multiply these guys because they're exponents, but this is not an exponent. 3 times 3 is 9, times another 3 is 27. This is W. Now, again, following PEMDAS, I've got an exponent to another exponent, so I need to be multiplying. 5 times 3 is 15. Multiply these, this is z to the 6th. 5 times 5, that is not 5 times 2, that is 5 times 5, 5 squared. That's 25, and that's w squared. So to get my final answer, 27 times 25, 675. Now notice that multiplication is all that's happening here, and it says when multiplying, I add my exponents. So I have w's and w's. So 5 plus 2 is 7. I already multiplied those guys. I've added those. I'm left with z to the 6th. That is my final answer. Second problem. Again, the 2 as an exponent goes to every piece. So I've got -5, and I'm squaring it. I've got a to the -3, and I'm squaring it. I've got b to the 5th, and I'm squaring it. Notice the next problem doesn't have an exponent outside, so I'm just going to do 2 times a times b cubed. Alright, -5 squared means -5 times -5. That is positive 25. This is going to be a to the -6th, multiply, b to the 10th, because I'm multiplying. 2 hasn't changed, a hasn't changed, b cubed hasn't changed. Whole numbers, 25 times 2, that's 50. I've got a to the -6, and I'm supposed to be adding it with a to the 1. -6 plus 1 is a to the -5. So I took care of those. B to the 10th plus b to the 3rd is b to the 13th. Now, you are not allowed to leave negative exponents. This is in the wrong spot, so my final answer, 50 is fine. B to the 13th is fine in the numerator. But a needs to flip to the denominator. Now, this is my final answer. Okay, the next one. This 3 goes, since this is a fraction, to everyone. So that means I have 3 that's being cubed, w squared that's being cubed, y cubed that's being cubed, divided by 6 that's being cubed, and z squared that's being cubed. You see how that 3 was on the entire fraction? It goes to every single piece. 3 cubed, we've already done, that's 27. Multiply these. Multiply. 6 to the 3rd power, you probably don't know, so type it in the calculator. You get 216. Z to the 6th. Now, 27 divided by 216, because that's what that fraction says. You are not allowed to give decimals, so we're going to make it a fraction. And the fraction is 1/8. So I have 1/8 when I reduce. W, y, and z, they are not same bases, so they will stay just as they are. Nobody was negative, so you can write the 1 or not write the 1, it's up to you. But you have to know that that reduces to 1/8. Next problem. Now notice this -2 goes to everybody, so before I distribute it, a negative means to flip. And since the -2 goes to all the numerator and all the denominator, both are going to flip. So I'm going to flip it first. And then everything is squared. When I flip everybody, the exponent is now positive. That negative went to everybody, so flip your numerator and denominator. Now, 2 goes to the 9, 2 goes to the 4, 2 goes to the b, 2 goes to the 45, 2 goes to the a, 2 goes to the b squared. That means I have 9 squared, a to the 4th squared, and b squared, divided by 45 squared, a to the 4th squared, and b squared squared. Notice that this 2 goes to every single piece. 9 squared, 9 times 9 is 81. Multiply these guys, they're exponents, so that is 8b squared. 45 squared, you probably don't know it, nor do I. That's 2025. A to the 4th being squared is 8, and that is b to the 4th. 2 times 2 is 4. 81 divided by 2025 is, again, no decimals, 1 over 25. Anything divided by itself is 1, so the a's are gone. Look at your b's. When I do 2 minus 4, I get a negative 2. That means it cannot be in the numerator, it must be in the denominator. Or you can say, hey, it's larger in the denominator, so 4 minus 2 is 2. Leave it in the denominator. However you like to think about that. Now you can go do your assignment that is attached.